Good morning, Geometry ESS. This is week 3, day 2. You should have already completed the exponential money game and exponential zombies. If you have not, please do so first because this is going to build on that information. Okay, so let's look at an example where we were doubling. Okay, so if we start with 1 and we keep doubling, we'll have 2, then 4, then 8, 16, 32, and so on. It's going to keep going. And if we try to graph that, I can't draw straight while I'm videoing at the same time, but it's okay. So we have 1, 2, 4, 8. You'll see that it gets big really fast. I'm not able to graph very many points. Okay? So what happens before our initial point? So if we started with 1, that is our initial. So before that, so if we work backwards, so going down from 32, 16, 8, 4, 2, 1, we're cutting it in half each time. So half of 1 would be a half. Half of that would be a fourth, or 0.25. Is it ever going to reach 0? Half of that is an eighth. Half of that is a 16th. So if you look, see the number pattern? So it's not going to get to 0. It's actually going to get very, very close to 0. So close, it may actually look like it touches it, but it actually doesn't. Okay, so let me show you what the graph looks like on here. So y equals, our starting number was 1. We are doubling each time, raised to the x power. So there's our graph. So it looks like it's touching our x-axis here, but if we actually plot the points, we're at 0.01, 0.003, 0.001, and it looks like it's 0. That's only because my computer is not showing enough decimals, but that's like 0.0006 and 0.0002. It's going to keep getting smaller and smaller where it gets closer to 0, but it never will actually cross it. That's called a limit, or in the terms of this is an asymptote. Right? It's a horizontal, sometimes vertical, line that the graph will never cross. It will get close to, but not actually cross. So whenever we have horizontal lines, it is y equals a number. And in this case, the number would be on the y-axis 0. So our graph is going to get closer and closer to y equals 0, but never cross over it. That is an asymptote. So let's look at another example. Okay. So let's say you're standing on a cliff and you go to drop a ball. Okay. It's 100 feet from each ball, or from the ball to the ground. So when it bounces back up, it's going to bounce up half as high. So it bounce up 50 feet and then come back down, and then bounce up 25 feet, down, bounce up 12 and a half, and it's going to keep going, halving each time. Will it ever actually get to the ground? In real life, yes, eventually the ball will stop, but in mathematics, it's not. It's going to get closer and closer to 0. So here is our equation. So the 100 is our starting amount. We're halving each time, so that's where that 0.5 comes from. And we're going to graph. So this one is going down. Okay. Why is it going down? Well, remember, when this number is bigger than 1, we have growth. When it's less than 1, we have a decay. So we have a decay function here. And if we look at our table of values, at 0, so 0 bounces, it started off 100 feet above the ground. After 1 feet, it's 50 feet above the ground. 2 feet is 25. 3 is 12.5. And we can keep going. And it's going to get closer to 0, but it's never going to reach 0. Now, once I got so far, you see these negatives. That's scientific notation. That's just showing that it's a really, really small number. You see that a lot in science. But for today, we're not going to worry about that. You just wanted to be able to recognize that it's going to get closer and closer to 0, but it's never actually going to cross 0. So this one has a asymptote of y equals 0 as well. Can the asymptote be a different number? Well, of course. So let's look at this rock problem again. Let's say instead of coming down and hitting the ground, it hit a second cliff that is 20 feet above the ground. Well, if it's hitting this cliff, so it's coming down, bouncing, going back up and down, bouncing here, it's never going to fall off that second cliff. I'm ignoring the fact that it could roll off. So other factors like that can change the problem, but keeping it simple, the ball comes down, bounces, and just bounces straight up and down. It will stay on this cliff. It will never actually hit this ground. So what that means is it will always be 20 feet above the ground. So that plus 20 here changes our problem and changes our graph. So if I put a plus 20, now look what happened. It's going to get closer and closer to 20. It's never going to go past that. That also will change. I got to change this here. Let's just do this. Delete that, and I will create a table for this one. There we go. It also changes our starting point because it's no longer 100 feet above the ground. It is 100 to the cliff and 20 to the ground. So our starting value is actually 120. And then the next one will be 70 feet. It halved it, but it's still at 20 feet above the ground. And then 45, and it's going to keep getting closer and closer to 20. So for that problem, our asymptote is y equals 20. So if we have the equations, real easy to see. It is whatever's being added or subtracted. It can be negative as well. So that is our asymptote. This is our y-intercept. This is where it starts, unless there's an asymptote. If there's an asymptote that's not 0, then the y-intercept is actually these added together. And then this number here is our growth factor or decay factor. So if it's bigger than 1, it grows. If it's less than 1, it decays. So by looking at the equation, we can identify some key features for our exponential functions. If we're looking at the graph, we can determine the same thing. So our asymptote is where it flattens out at. Our y-intercept is our starting value, so where it crosses the y-axis. And the growth or decay factor is a little bit harder to tell on graphs. It's best if you have the equation or the list of numbers. So those 3 features is what you need to be able to recognize from an exponential: the y-intercept, the growth decay factor, and the asymptote. So I've had trouble before with asymptotes. It's very hard to understand, especially on videos. So hopefully this has cleared some things up. If you have any questions, make sure you reach out to me.